Hello and welcome to the Certified Ethical Hacker Study Guide. In this video, we will discuss Chapter 11.3, Understanding Authentication. Please like, subscribe, and hit the notification bell. Now let's flip into the first topic. After this short break. The problem of unauthorized users accessing resources on a network is a major concern for security professionals. An organization that introduces wireless technology to the mix increases the potential for security problems. The 802.1x standard, discussed in the following section, addresses the issue of authentication. Some routers by default do not require authentication, which could leave a corporate network at risk. GAP-0.5s. Now let's jump on into the next topic, right after this short break. Because there must be a method to ensure that others with wireless NICs can't access resources on your wireless network, the 802.1x standard defines the process of authenticating and authorizing users on a network. This standard is especially useful for WLAN security when physical access control is more difficult to enforce than on wired LANs. To understand how authentication takes place on a wireless network, review basic authentication concepts in the following sections. Many ISPs use point-to-point protocol, or PPP, to connect dial-up or DSL users. PPP handles authentication by requiring a user to enter a valid username and password. PPP verifies that users attempting to use the link are indeed who they say they are. GAP-0.5s. Now let's crash on into the next topic, right after this short break. Extensible Authentication Protocol, or EAP, an enhancement to PPP, was designed to allow a company to select its authentication method. For example, a company can use certificates or Kerberos authentication to authenticate a user connecting to an AP. A certificate is a record that authenticates network entities, such as a server or client. It contains X.509 information that identifies the owner, the certification authority, CA, and the owner's public key. You can examine an X.509 certificate by going to www.amazon.ca. This website redirects you to the secure HTTPS URL, where you click the padlock icon at the left of the address bar in Chrome. The following EAP methods can be used to improve security on a wireless network. Extensible Authentication Protocol Transport Layer Security, EAP-TLS. This method requires assigning the client and server a digital certificate signed by a CA that both parties trust. This CA can be a commercial company that charges a fee or a server configured by a network administrator to issue certificates. In this way, both the server and client authenticate mutually. In addition to servers requiring that clients prove they are who they say, clients also want servers to verify their identity. Protected EAP PAP, uses TLS to authenticate the server to the client but not the client to the server. With PAP, only the server is required to have a digital certificate. See RFC 2246 for more information on TLS. Microsoft PEEP. In Microsoft's implementation of PEEP, a secure channel is created by using TLS as protection against eavesdropping. 802.1x uses the following components to function. Supplicant. A supplicant is a wireless user attempting access to a WLAN. Authenticator. The AP functions as the entity allowing or denying the supplicant's access. Authentication server. This server, which might be a remote access dial-in user service Radius server, is used as a centralized component that authenticates the user and performs accounting functions. For example, an ISP using Radius can verify who logged on to the ISP service and how long the user was connected. Most Radius servers are *NICs based, but the Microsoft implementation of Radius is called Internet Authentication Service, IAS, in Windows Server 2000 and Windows Server 2003, and is called Network Policy Server after Windows Server 2008. Until EAP and 802.1x were used on wireless LANs, a device, not a user, was authenticated on the WLAN. Therefore, if a computer was stolen from a company, the thief could connect to resources on the WLAN using the computer for authentication. The following sections describe security features introduced in 802.11b and 802.11i, GAP-0.5s. Now let's dance on into the next topic, right after this short break. Wired Equivalent Privacy, or WEP, part of the 802.11b standard, was developed to encrypt data traversing a wireless network. For some time, it gave many security professionals a false sense of security that wireless technology could be just as safe as wired networks. Unfortunately, WEP has been torn to shreds by security professionals, professors from major universities, and hackers who post ways to crack WEP encryption. WEP encryption is easily cracked due to a flaw in its RC4 encryption algorithm. The encryption key used by the algorithm is a 24-bit initialization vector, IV, in combination with a default key. The 24-bit IV is too short and easy to break. Some argue that WEP is still better than no security at all, and when it's combined with the security of a virtual private network, VPN, they claim that WEP works well for home users or small businesses. Still, many saw a need for a better way to protect WLANs, GAP-0.5s. Now let's fall on into the next topic, right after this short break. Wi-Fi Protected Access, known as WPA, WPA2, and WPA3, specified in the 802.11i standard, is the replacement for WEP, which is known to have cryptographic weaknesses. WPA improves encryption by using Temporal Key Integrity Protocol, or TKIP. TKIP has 4 enhancements that address encryption vulnerabilities in WEP. Message Integrity Check, MIC, pronounced MIC and also called Michael, is a cryptographic message integrity code. Its main purpose is to prevent forgeries, which are packets that attackers create to look like legitimate packets. For example, an MIC uses a secret authentication key, which only the sender and receiver know, and creates a tag, a message integrity code, generated from the key and message sent to the receiver. The sender sends the message and tag to the receiver, who must enter the key, tag, and message in a program that verifies whether the tag created with the 3 input fields is equal to the tag the program should have created. You don't need to memorize this process, but should understand that MIC corrects a known vulnerability in WEP, Extended Initialization Vector, IVOI, with sequencing rules. This enhancement was developed to prevent replays. In a replay, an attacker records or captures a packet, saves it, and retransmits the message later. To prevent a replay from occurring, a sequence number is applied to the WEP IVOI field. If a packet is received with an IV equal to or less than the sequence number received earlier, the packet is discarded. GAP-0.5s. Now let's drive on into the next topic, right after this short break. A Wi-Fi Protected Setup, or WPS, is a wireless authentication standard created to allow users to add devices easily and securely to a wireless network. WPS makes this process easier by eliminating the need for a user to enter a passphrase. Rather, the user simply presses a button on the router and the WPS-enabled device pairs with the router. Chances are, if you have a modern router at home, it is capable of WPS. WPS might sound like a great solution, but a major security flaw was discovered in late 2011. This flaw allows an attacker to gain access to a network remotely without knowing the WPA2 password, GAP-0.5s. Now let's drop into the next topic, right after this short break. It's probably no secret that hackers use war driving around with inexpensive hardware and software that enables them to detect access points that haven't been secured. Surprisingly, some APs have no passwords or security measures, so war driving can be quite rewarding for hackers. As of this writing, war driving isn't illegal. Using the resources of networks discovered with war driving is, of course, a different story. War driving has now been expanded to include war flying, which involves drones with an antenna and the same software used in war driving. The testers used Kismet, covered later in this section, which identifies APs that attempt to cloak or hide their SSIDs. If you find this video useful, please hit the like button, leave a comment, and subscribe to the channel. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. Thanks for watching. See you on the next one.